Hi, this is our data analysis project on the effect of bench press angle on chest activation. So we're going to start first with some introduction and background. The bench press is a compound exercise performed with a barbell meant to target the chest muscles. Now, something important to note is that there are three different heads of the chest: the clavicular, sternal, and costal, which we will refer to as the upper, mid, and lower chest. And the generally accepted idea is that a lower angle bench press is going to target more of the mid and lower chest, and a higher angle targets more of the upper chest and shoulders. So now onto the problem. As we just mentioned, changing the angle on your bench press is going to affect which muscles are being targeted the most during that exercise, and nobody knows exactly which angle is the best to target certain parts of your chest, such as the upper or mid chest. There are lots of varying sources online giving different recommendations, and our goal is to figure out which is the optimal angle to bench press at for each part of the chest. More specifically, our research question is: how does changing the bench angle, for example from flat, incline, or decline, affect muscle activation in each pectoral muscle during a barbell bench press exercise as measured by EMG? And our hypothesis is that increasing the bench angle, say from flat to incline, will result in greater activation of the upper pectoral muscles compared to the flat and decline angles. And we predict the angle that will produce the most activation for the mid chest is going to be 0, or horizontal, and the angle that produces the most chest activation for the upper chest will be 30 degrees.
Procedures. For the experiment, we had the EMG sensor placed in 3 different locations on the pectoral muscle on the participant, and then we had the participant bench the weight at 3 different angles. Prior to the test, we did a warm-up, and prior to doing all the tests, we did a 1 rep max to get a baseline of the experiment. For each test, we had 5 reps at a load of 60% of 1 rep max, and then 3 sets to ensure proper data collection. We did that for each incline, flat, and decline of that we needed. Furthermore, we did rest periods of multiple days in between each test. So for that, we had a location of upper chest, middle chest, and lower chest. In between these 3 locations, we also had the same with the EMG. Has 2 sensor locations for 1 measurement. So we had essentially a ground and a positive to establish the connection. The ground, if you will, stayed in the center of the middle chest, while the other connection would alter between upper, middle, and lower chest for the different experiments. For the sensor specifications, the sensor could read a voltage range of 0 to 10 millivolts. For this experiment, the ranges were for anywhere from 0 to about 2 millivolts for this experiment.
So now we can get into the results and discussion of our experiment. So since our experiment is muscle-based, trying to find the muscle activation of different regions of the chest during different angles of incline, there's not really a mathematical model that can be used to accurately predict the results of our experiment. However, there have been several studies done that are similar to what we're trying to do. Some of the results suggest that the maximum values of the upper pectoral was during the 30 and 45 degree incline, with results of 122.5 MVIC and 124.8 MVIC. During the horizontal test and negative 15 degree incline test, the lower pectoral was what achieved the maximum muscle activation, with results of 98.4 MVIC and 99.6 MVIC. Also, for both the lower and upper heads of the pectoral muscle, the muscle activation was highest during the concentric phase rather than the eccentric phase for each bench angle. And MVIC is the maximum voluntary isometric contraction, and it's one of the most accurate ways to measure muscle activation. So now we can go into our data that we collected. Here's a visualization of the raw data that was collected during our experiments. And as you can see, there's 9 different groups, or 9 different collections. And they're split by the region of the pectoral. So there's the upper, middle, and lower region. And then the bench angle, which there's horizontal, negative, and positive bench angles. But just by looking at this graph, there's nothing actionable we can take from it. So we need to do some data processing. And for that, we chose to do a root mean square for each of these. So as you can see, there's the root mean square values on the left, and these can be visualized in the graph on the right. And as you can see, the upper chest was always had higher activation than the middle chest and lower chest, and the middle chest always had higher activation than the lower. So we'll get into normalizing the data later. When it comes to the individual regions, the negative bench angle was what we actually found to be the highest activation for the upper chest, which goes against the previous findings. And for the middle, it was found to be the positive bench angle, as well as for the lower.
This is our normalized data. We took the negative bench angle and positive bench angles and divided them by the 0-degree bench angle to get a qualitative idea on the behaviors of the muscle activation with a change in bench angle.
Now, on to our analysis. We performed a two-way ANOVA test on our data. We tested 2 null hypotheses, the first one being that muscle activation does not differ across the 3 chest regions. Our second null hypothesis was that muscle activation does not differ across the 3 bench angles. And we could not test for interaction since we did not have any replication in our data. Below, we can see the results of our ANOVA. For our first null hypothesis, we found a p-value of 0.0045, and for our second null hypothesis, we found a p-value of 0.668. This tells us that we can reject our first null hypothesis, and we cannot reject our second. With the results of our ANOVA test, we can now draw conclusions. The first conclusion is that there is no statistically significant effect of bench press angle on overall muscle activation across the chest regions. The second conclusion we can draw is that muscle activation varies significantly across the chest regions, indicating that different regions engage differently during the bench press regardless of angle. We found that the single highest upper pec activation was on a decline angle, which is opposite to what we predicted. We can conclude by saying our hypothesis is not supported by the data. Incline angles did not produce the most upper pec activation, and horizontal angles did not produce the most mid-chest activation. Additionally, the angle of our bench did not seem to affect the region being targeted during the exercise. Now, on to the limitations and recommendations for future experiments. Our first limitation is going to be the lack of replication. Since no repeated measurements were performed, our results are less reliable. The second limitation is going to be the limited bench angles. We had a setup which only allowed for 3 different angles. Ideally, we would have liked to test more angles. Our third limitation is going to be the EMG measurement constraints. EMG readings are susceptible to signal noise, which could affect the accuracy of our results. As for recommendations, we could increase the sample size and replicates. We could expand the range of bench angles. We could control for individual differences. This means that we would account for participant factors such as chest anatomy, strength, or training experience. And we could also explore long-term adaptations to the experiment, as this would be a more accurate way to measure if the muscle is actually growing over time. Here's a list of our references. Thank you for watching. I hope you enjoyed.